Welcome to this lesson on multilevel grouping and custom aggregations in Pandas. Multilevel grouping and custom aggregations in Pandas. Welcome! Today we will master advanced grouping and aggregation in Pandas. Learn why grouping by more than one column is so powerful. See how custom functions reveal new insights from your data. We will practice with the Titanic dataset, exploring survival rates by gender and passenger class. Ready? Let us dive in. Running the cell now. Let us start by setting up the data we will use. First, let us suppress warnings so our notebook stays clean and easy to read. We want to prevent warning messages from cluttering the output. We import the warnings library. Import numpy as np. We set the random seed to 42 for reproducibility. We turn off all warnings to focus on our results. Running the cell now. This initial setup code doesn't produce visible output but is crucial for a clean and consistent learning experience. By setting a random seed and suppressing warnings, it ensures that any group data or custom aggregations you generate later will be reproducible and free of distracting messages. This foundation lets us focus clearly on mastering multilevel grouping and custom aggregation techniques in Pandas. You can re-enable warnings later if you want to learn more about them. Let us load the Titanic dataset, which captures survival on the famous ship. We are about to set up the Titanic data for our analysis. We import the Pandas library. We load the Titanic dataset from GitHub using its URL. We read the CSV data into a data frame called df. We print the shape, showing rows and columns. We preview the first 3 rows so we know what to expect. Running the cell now. The output confirms our Titanic dataset loaded successfully with 891 rows and 12 columns, including key features like survived, P-class, sex, and age. Noticing these specific columns sets the stage for our multilevel grouping, as we will group by several attributes to uncover survival patterns across classes, genders, and more. This initial glimpse ensures we understand the data's structure before applying custom aggregations. Notice columns like sex, P-class, and is survived. These will help us with grouping. Take a moment to think about why we might want to group by more than one column. Why group by multiple columns? Grouping by more than one column lets us break down patterns within subgroups. For example, how likely were women in first class to survive? Did survival differ by sex across all passenger classes? Pandas lets us answer these questions in just a few lines. Running the cell now. Let us experiment with actual code to see this in action. Let us see how many people belong to each gender and passenger class. We check how many rows fall under each value of the sex column. Next, we check the counts for each passenger class using P-class. This gives us a sense of our group sizes. Running the cell now. Here, we see the counts of passengers by sex and by passenger class, showing there were more males, 577, than females, 314, and most passengers were in third class, 491. This preview helps us understand the composition of the dataset before grouping by both columns to explore survival patterns within these subgroups. Noticing these distributions sets the stage for analyzing survival rates by combining sex and P-class. Being familiar with our groups helps us make sense of results later. Now we group by both sex and P-class and count the number who survived for each subgroup. We tell Pandas to group the data first by sex, then by P-class. We select the survived column for these groups. We sum the survived values, so we count how many survived in each group. Running the cell now. This output shows the number of survivors broken down by both sex and passenger class, highlighting subgroup survival patterns. Notice that female passengers in first class had the highest count of survivors, 91, illustrating how grouping by multiple columns helps reveal detailed trends across categories. This aligns with the lesson's goal of analyzing survival likelihood within combined subgroups. Do you notice which group had more survivors? Let us now calculate the survival rate instead of just the count. We use the same groups as before, sex and p-class, focusing on survived. By taking the mean, we find survival rates for each subgroup. Printing these survival rates lets us compare odds by gender and class. Running the cell now. This output shows the survival rates broken down by both sex and passenger class, illustrating clear patterns. Females in higher classes had much higher survival rates, especially in first and second class, compared to males whose survival rates were low across all classes. Grouping by multiple columns here reveals these nuanced subgroup differences, highlighting how combining factors helps us understand survival likelihood more precisely. Can you spot the best survival chances? You may notice the output has a special kind of index after grouping. What is a multi-index? Grouping by multiple columns creates a multi-index for the rows. A multi-index lets Pandas identify groups based on several columns. This structure allows us to drill deep into subgroup details. We can reset it back to columns using .reset_index. Running the cell now. Let us see how to turn the index back into columns. We need to turn our multilevel index into visible columns for easier use and plotting. By using reset_index on survival_rates, we convert the index back to columns. Now, sex and p-class become normal columns again. Printing the top rows shows the new data frame structure. Running the cell now. This output shows the survival rates grouped by both sex and p-class, with the multi-index turned back into regular columns for easier viewing. Notice how each row uniquely combines these two categories, allowing you to compare survival trends across different groups, which was the main purpose of creating the multi-index. This highlights how Pandas efficiently organizes complex groupings and lets you extract meaningful summary statistics. Does this format feel more familiar? Try grouping by 3 columns on your own next. Let us now use several summary functions at once with the fair column. We use group B on sex and p-class again, this time looking at fair. The agg method lets us apply multiple summary stats like count, mean, and median. This provides an overview of ticket prices in each group. Running the cell now. Here we see a multi-index created by grouping the data frame by both sex and p-class, with fair statistics aggregated simultaneously. Notice the rows are indexed first by a sex and then by a p-class, showing counts and fair averages for each subgroup. This highlights how multi-indexing helps organize and access complex group summaries efficiently. Try adding minute and a max to see the range of fairs too. Let us compute something more specific, the percentage of missing age values in each group. We add a comment explaining that we're using a custom aggregation function to find the percent of missing values in the age column. We define a function named %_missing that takes a series, column, as input. The function computes the mean of null values in the series, then multiplies by 100 to get a percentage. We group the data frame by sex and p-class and apply the %_missing function to the aged column to get missing percentages per group. We print out the resulting series to see the percent of missing age values for each sex and p-class group. Running the cell now. Here, the output shows a multi-index with sex and p-class as the row indices, illustrating how Pandas groups data by multiple columns. Each value represents the percentage of missing age data within that subgroup, highlighting variation in missingness across gender and class. This reinforces the lesson that a multi-index helps us organize and analyze group data by identifying distinct groups based on several columns. Custom functions let you tailor group analysis to your exact needs. We can also specify different aggregations for each column using a dictionary. We add a comment explaining that different aggregation functions will be applied per column using a dictionary. We start defining a dictionary named agg_dict to specify aggregations for each column. We assign the list, mean, std, to the key fare, indicating we want these statistics for the fare column. We assign the list median %_missing to the key age for median and a custom missing data function. We close the dictionary definition. We call group B on the data frame df by sex and p class and apply the ag_dict aggregations. We print the first few rows of the resulting aggregated data frame to see the summary. Running the cell now. This output shows a multi-index resulting from grouping rows by both sex and p class, with aggregated statistics for fare and aged under nested column labels. Notice how the hierarchical row index clearly separates groups, while the columns display multiple aggregation functions side by side, highlighting the flexibility of multi-index to organize complex summary data. This helps us easily compare different statistics across multiple category levels in one concise data frame. What other custom summaries would be useful in your work? Let us make our findings even clearer by sorting groups by their average fare. We sort the group summary by the mean fare in descending order. This helps us spot the highest paying groups quickly. This ranking reveals how class and gender relate to ticket price. Running the cell now. This output shows a multi-index data frame sorted by the mean fare, with rows grouped by both sex and p class. Notice how each combination of these two columns creates a unique group, allowing Pandas to aggregate multiple statistics like mean, STD, and median for fare and age, alongside %_missing. This illustrates how multi-indexing captures complex groupings in a clear, hierarchical format, essential for multilevel data analysis. Try sorting by a different column for more insights. Let us use a lambda-like trick to see how children and adults fared in each class. We make a new column is minor, which is true if age is less than 18. Grouping by p class and is minor lets us split results by class and youth status. We calculate the average survival rate for each combination. Printing this shows which groups had the best odds for young versus older passengers. Running the cell now. This output shows survival rates grouped by passenger class, p class, and age category, is minor, which creates a multi-index for the rows. Notice how each class has two survival rates, one for minors, true, and one for adults, false, illustrating how Pandas organizes data when grouping by multiple columns. This multi-index clearly distinguishes survival trends within each class based on age, helping us compare subgroups effectively. Imagine what other groupings you could create with simple column logic. We can reshape the last result into a regular table with columns for minors and adults. The unstack method moves one grouping level into columns. Now we have p class as rows, is minor as columns, and survival rates neatly arranged. This makes big groupings easier to visualize. Running the cell now. This output shows a multi-index data frame where the rows are grouped by p class and the columns reflect the is minor status, created by unstacking the group data. Notice how the table clearly separates the survival rates by passenger class and whether they are minors, making it easier to compare these two categorical variables side by side. This illustrates how a multi-index can organize complex group data for clearer interpretation. Tables like this are handy for creating charts next. Let us try a practical scenario, grouping by port and class to see fare and age differences. We group by embarked, which shows where each person boarded, and p class, the ticket class. We calculate the median fare and mean age for every group. The result shows differences between ports and classes. Running the cell now. This output shows the median fare and average age grouped by both embarked port and p class, demonstrating a multi-index with two levels. Notice how each combination of embarkation point and passenger class has its own row, allowing precise subgroup summaries. This clearly illustrates how grouping by multiple columns creates a hierarchical index to organize aggregated statistics effectively. Do you spot trends in port, age, or price? Let us try interactive grouping, allowing you to choose columns and stats. This is a practice section where we use input to let you explore custom groupings. Ask the user for the first column to group by sex, P-class, or embarked. Ask the user for the second column to group by sex, P-class, or embarked. Ask the user which statistic to calculate, mean, count, or median. Ask the user to specify the numeric column to summarize, fair, age, or sub-SP. Group the data frame by the two chosen columns, then aggregate the target column using the specified statistic. Print the resulting grouped and aggregated data to show your custom result. Running the cell now. This output shows a multi-index resulting from grouping the data frame by sex and P-class columns, then calculating the mean fair for each subgroup. Notice how the rows are nested under each sex category, with corresponding P-class values, illustrating how multi-index organizes data hierarchically based on multiple group keys. This structure makes it easy to analyze statistics within combined categories, demonstrating the core purpose of multi-index in Pandas grouping. Pause the video now and try several combos. If you are learning on YouTube, please like and subscribe for more Pandas guides. Let us wrap up with some tips to help you avoid common mistakes and work faster. Best practices and performance tips. Group only by columns you need less memory, faster code. Try .ag with built-in and custom functions together. For big data, watch for NaN and missing values. Use .sort_values to help spot most important groups. Reset unwanted multilevel indexes for tidy tables. Troubleshooting. Errors about missing columns usually mean a typo or missing reset_index. For Kira, check all Group B columns existed in your data frame. Use df.info to check your columns types if grouping fails. Running the cell now. With these habits, your Pandas workflow gets easier and more robust. Here is a challenge: create a new feature, family size, then group survival rates by family size and class. We start by stating the challenge, calculating total family members on board and average survival by family size and class. We add a new column's family size to the data frame by summing the number of siblings, spouses, parents, children, and adding one for the passenger themselves. Next, we group the data frame by family size and passenger class P-class, then calculate the mean survival rate for each group. Finally, we print the first 10 rows of the grouped survival means to observe the survival trends by family size and class. Running the cell now. This output shows the average survival rate grouped by family size and passenger class, illustrating how survival varied across these combined factors. Notice that larger families in higher classes tend to have higher survival rates, highlighting the benefit of grouping by just the necessary columns to reveal meaningful trends efficiently. This aligns with best practices by focusing on relevant groups to keep code performant and insightful. What patterns do you notice for solo travelers versus big families? Let us finish by visualizing how survival rates compare by group. We add a comment describing the purpose of this code block, visualizing survival rates by class and gender. We import the matplotlib.pyplot library to enable plotting capabilities. We group the data frame by sex and P-class, then calculate the mean survival rate for each group and reshape it with unstack. We create a bar plot from the survival rates to compare groups visually. We set the title of the plot to explain what is being displayed. We label the y-axis to indicate that it represents survival rates. We display the plot so that the visualization appears on the screen. Running the cell now. The bar chart visualizes survival rates grouped by gender and passenger class, highlighting key differences across these groups. Notice how grouping by just sex and P-class simplifies the data, making trends clearer and the plot easier to interpret. This aligns with best practices by focusing on essential groupings to efficiently reveal meaningful patterns in survival. Try experimenting with other groupings or using Seaborn for enhanced charts. Let us quickly review what we have learned today. Recap: key concepts for multilevel grouping and custom aggregation. Use Group B with lists for multiple columns. Custom aggregation functions help answer unique questions.
Chain with .ag for clear, powerful group summaries. Use .reset_index and .unstack for easier reading and plotting. The next time you need detailed breakdowns or hidden patterns, you will be ready. Running the cell now. Practice with your own datasets to strengthen these skills. Thank you for joining. If this lesson was helpful, hit like and subscribe on YouTube. Share your own Group B ideas in the comments. Happy coding with Pandas. Running the cell now. You did great today. Keep exploring Pandas and see you in the next lesson.